I'm hoping that this is working. We'll find out soon. Aaron, just, before we get started, I need to say to you that Meredith insists that the next time she's absent, you and I do a recording for her, because she really doesn't like the idea that we keep having to record these lessons for you, but she doesn't seem to get the same treatment in return. So out of fairness, next time she's absent, we have to record, no matter what. All right, so today we're going to have a bit of a short class because, well, what can I say? You missed German chocolate cake and cookies at Sister Edna's reception. Meredith and I were there to enjoy. Anyhow, we're now left with just about half an hour for class, so we'll see how we do, trying to record for half an hour, and if indeed I can put that on YouTube without any protests. All right. Well, today our focus is on inverses, specifically inverses of matrices, and so I thought what we would do is start out by talking a little bit about inverses in general. So, Meredith, since you are my class today, tell me, if I said to you, what is the additive inverse of the number 3? What would you tell me?
-3.
-3. Very good. And could you explain to me what it is about -3 that makes it the additive inverse of the number 3?
Because when you add it to 3, you get 0.
And 0 is, it has what special name or what special property in the world of real numbers?
Well,
What happens if I add it to a number?
it doesn't change anything.
Okay, and if I, either on the left or on the right, I can add it before or after the number and it still doesn't change. In other words, the number retains its identity. So 0 has the distinction of being called the identity number, or the identity for addition. Because when you add it to a number, it doesn't change the value of the number. And since 3 plus -3 is equal to 0, the identity, then -3 is considered the additive inverse of 3, and vice versa. What about if I ask you, what is the multiplicative inverse of the number 3?
1/3.
1/3. Very good. All right, so what is it about 1/3 that makes it the multiplicative inverse of 3?
When you take 1/3 and you multiply by 3, you get 1.
Which is?
It acts as multiplication, like 0 does for addition, and it doesn't change anything when you multiply it.
All right, multiplicative identity for real numbers. Very good. All right. So, like real numbers, like real numbers have a concept of inverse, we also have that concept of an inverse for a matrix. What do you think, or how do you think we might define, based on what we just talked about, how would we define the inverse of a matrix? Like if I had just some matrix, you don't have to tell me what the inverse is, but if I had this matrix, what would have to be true about its inverse in order to say, yep, that's definitely the inverse of the matrix that's given here?
It would have to, your answer would have to come out to be, I'm going to say 1, 1, 1, 1.
And what is 1, 1, 1, 1?
The multiplicative identity.
So, if I multiply, excuse me, I just gave that away, didn't I? You said the answer has to be 1, 1, 1, 1. What answer is that? What's the operation?
Well, this is in multiplication.
Okay, so I need to find a number, or not a number, I need to find a matrix, and we'll call that the inverse of A. This is matrix A, and we also write that as A with a -1 exponent. That's understood to mean inverse. Now, you said this is the multiplicative identity. What is it about this matrix 1, 1, 1, 1 that makes it an identity matrix?
Well, when you well, I just thought because one is the multiplicative identity number, so then I just thought with each like number in a matrix, you have to get that same
All right, so if I multiply, let's put in the matrix 1, 1, 1, 1 in the calculator here. Read it. So I'll create a 2 by 2 matrix here, and its entries are 1, 1, 1, 1. And let's use the matrix that we had over here. Actually, I called this one A, but I'm going to have to rename it B in order to work with the calculator. At least it's easier to rename it than it is to re-enter a matrix in the calculator. So we'll switch that. And then matrix B. Let's edit that. That will also be a 2 by 2 matrix, and that's our matrix from the smartboard, 1, 2, 3, 4. So, if A is the multiplicative identity, then if I take A, matrix A times, oops, let's try that again, matrix A times matrix B, then I should get matrix B back, right? I mean, it shouldn't change matrix B. If I take this matrix times this one, I should just come right back to this matrix, but this is really the identity.
Are we looking for the inverse, or are we looking for the answer?
Well, we're looking for the inverse, but before we can get there, I wanted to go back and verify what you said about this one being the identity matrix. So
okay,
that's
well,
what I'm doing at the moment.
Okay, well, that's wrong. I was wrong.
Okay, so we've got a problem here, because when we take 1, 1, 1, 1, this matrix, times matrix B, if this is the identity, then this times matrix B should give us matrix B, and it didn't.
Yes.
So something went wrong. So let's back up and see if we can fix this. What do we need to change about this matrix to make it the identity?
Let's see 1, 0, 0, 1.
Oh, a change of tune. All right. Let's go back and try that. I think that looks much better personally. Let's check and make sure that we aren't both wrong. All right, so back to matrix A. I'm going to edit that and make it 1, 0, 0, 1. Right now, see matrix A times matrix B. And if it's really the identity matrix, then we should be able to multiply it either on the left or on the right by matrix B. And we'll still come out with matrix B. And there it is on the left. Let's try B times A. Looking on the edge here. B times A. And there it is. All right, so 1, 0, 0, 1 is indeed the 2 by 2 identity matrix. So what we're looking for here is a matrix, this inverse matrix, that we can multiply by matrix B and come up with the 2 by 2 identity matrix. That's how we define the inverse of the matrix. And we should be able to multiply in either order, either B inverse times B or B times B inverse. Either one of those should give us the identity matrix. All right, so to get some insight about how to do that, unless you already have some insight about how to do it, do you have an idea how we might go about doing that? Or do you remember? Have you found inverses before in other classes?
I mean, we found inverses, but I can't honestly tell you.
Okay. Your calculator will do it, and we will resort to the calculator, but not yet, because we need to understand what's going on behind the scenes. Yeah, I mean, we always have to have some sense of appreciation for what the calculator's doing for us, and maybe the best way to do that is to do it the hard way, the manual way. I shouldn't say the hard way, that sounds so negative. We'll do it manually, and then once we've learned what the calculator's doing and learn to appreciate it, then we'll use the calculator.
So can we just take matrix B, or take matrix A divided by matrix B?
And how do we divide matrices?
That is a great question. I'm sure.
Let's try that on the calculator and see what happens. So matrix A divided by matrix B. Can you believe that?
When I came in at the right time, it worked out just right.
We tried to divide one matrix by another, and we get this error in the calculator that says standard type. How could that be?
I don't know.
Is this calculator trying to tell us that matrix division is not defined?
Apparently.
I think it is. It doesn't like that at all. And in fact, it's true. You don't.
Meredith probably doesn't like it either.
It's true. Matrix division. Oh, and by the way, Miss Hammer, you're being recorded. We're recording for Erin today.
Hi, Erin.
And we're hoping that she can hear okay. I had some issues with my microphone earlier on, so we'll see whether it's actually recording. We may get nothing but images, and she's going to wonder, what are they saying? She's missing a lot. All right, so matrix division is not defined, so we better find another method for doing this. What should we do?
Well, if it was just numbers, we would multiply by, okay, well, this is going to sound silly, but to multiply by the inverse of B, but that would, that's what we're doing. Yeah. So,
You're right.
Yeah, so.
Let's look at an example here, and I think this will help. I want to do a little bit of backtracking, and let's suppose that you were trying to solve an equation like this, or a system of equations like this. Let's say, and the subscripts will make sense a little more later on in the example. Let's say we wanted to solve a system like that. How should we do that?
You can just subtract them.
Okay, so we could subtract one from the other and try to get one of those variables to cancel out. What if we wanted to use matrices? How would we do that?
Well, you would have to put those numbers in a matrix.
Okay, you want to, how about if you come up with that augmented matrix looks like? So Erin will know that you're not just slacking off today in case you can't hear us.
That could never happen.
So she can't hear, so how would she know that this is me and not you?
Well, she'll probably recognize a change in the handwriting, I'm thinking.
Since we skipped x of 2, do I need to put a 0 there?
No, let's just, we won't worry about that sticky point today. Good question, but we're not going to worry about it. All right, so we could put that in a matrix, an augmented matrix, and then we could row reduce it and get ones on the diagonal and zeros below. And if we wanted to be really snappy, we could even get zeros where both of the 2's are. And then we could just read the solution right off of the matrix, the row reduced
I'm
matrix.
sorry for this interruption, but there's been a glitch with the sound system. So sophomores have just gone to lunch and freshmen have just gone to music, so we have to extend for the period. So for those
Good.
people who are in class right now, for the period, it's going to be extended a little bit, and we're going to just let you know what's going on, so you might just give the last 10 minutes study until we can get this off. taken
I
care
don't know,
of.
but
Sorry
you know,
about the
Mr. Hall
mistake
is
here.
building something down there. I wonder, you know,
Mm.
it's very temperamental, as you know.
Yeah, yeah, I know.
All that.
That's all right.
All right, over on the right-hand side, kind of at the top, Meredith, will you write another system of equations for us? And here it is, x sub 2 plus 2x sub 4
Oh, whoa. Sorry.
or 24 equals 0. And 2x sub 2 plus 3x sub 4 equals 1. And then will you write the augmented matrix for that system? Okay, now we're going to do something real, I think it's really snazzy. Notice that the augmented matrices both have the same entries on the left-hand side.
Yes, I did.
Wouldn't it be nice if we could write a new augmented matrix that incorporates all of this information in one?
No way.
Let's try it. Let's start a new one down at the bottom, and you might, give yourself some more room. Here's a new augmented matrix. Guess what the left-hand side's going to be?
This.
Yes. And on the right-hand side, first column is our 1, 0 in the first set of equations. And the second column is what? Yep, and then finish it off. Now, what this means is, we've incorporated all 4 of these equations into this one augmented matrix. So I've got, you got 1, x sub 1 plus 2x sub 3 equals 1. And if we multiply here, well, let me say, we could also write it like this, 1, 2, and I'll erase this in a second. 2 goes, hang on a second. Yeah, x sub 2, x sub 3, x sub 4 equals, and then our 1, 0, 0, 1. So this is another way of writing this shortcut method. Because if I multiply these two matrices, I've got 1 times x sub 1 plus 2 times x sub 3, and that's got to be equal to first row, first column entry of the product, which is 1. Well, that's just this equation up here. Next one, if I want the first row, second column, I go first row here, second column here, so 1x sub 2 plus 2x sub 4 equals 0, and that's this. And then if I want first row, first column of the product, second row, first column, I've got this times this, so 2x sub 1 plus 3x sub 2 equals 0. And that should be, that's an x sub 3, I can't read my own handwriting. That's this one. And then if I want second row, second column of the product, this 1 over here, I take second row, second column, so I got 2x sub 2 plus 3x sub 4 equals 1. 2x sub 2 plus 3x sub 4 equals 1. So this is a condensed way of representing all 4 of these equations. And look what we got here. The matrix times some other matrix that gives us the 2 by 2 identity matrix. This guy's going to be the inverse. Do you see that? We said back on this other page, we said we were looking for, now this is another matrix, but same concept. What we started out looking for was a matrix that we could multiply by a given matrix to get the identity. And we said this would be called the inverse. This again. A matrix that we can multiply by a given matrix to get the identity. This is our inverse.
That's not even real numbers.
Oh, well, we haven't gotten there yet. We're just talking about the method. Don't worry, we're going to solve it.
Okay.
I just want you to see that if we row reduce this system over here, this matrix, which represents this system of equations, if we row reduce this, then we're going to be able to read our inverse right off of the right-hand side of the matrix. We'll have 1, 1, 0, 0 over here, and what's on the right-hand side will be our inverse. So it's a pretty cool method because it uses what we already know about this as an augmented matrix and row reduce it and use that to solve the system of equations. Pretty cool stuff. So let's do it. Let's do it with this. Oops. Let's do it with this matrix. This 1, 2, 3, 4. But maybe I should do a new page. All right. Copy. This guy. So I've got my matrix, and then I'm going to put on the right hand side. I'm going to put 1, 0, 0, 1, and then we'll row reduce that. So here's the matrix 1, 0, 0, 1. And we'll row reduce it. What's the first step?
Take row 2 times row 3 minus 3 over 1.
Row 2 minus
Yes.
3, row 1. All right, so row 1 stays the same. And down here, row 2 minus 3, row 1. So that gives us the 0 we want here. And then row 2, 4 minus 3 times 2, so negative 2. And row 2 minus 3, row 1. Row 2 minus 3, row 1. Let me know if I made any mistakes there, please.
Nope, you're good.
All right, and then what's next?
And then you're going to take row 2 divided by negative 2.
Good. So 1, 2, 1, 0, row 2 divided by negative 2. So 0, 1, 1.5, and negative 0.5. Check me, please. Easy to make a mistake.
I'd love to, but I don't.
Your second mistake. Yeah. So when we finish, we'll back up for a second. She's telling me what to do.
You know, it's so bad for an uneducated, mathematically uneducated person that the terminology doesn't even.
Oh, okay.
It's really bad,
So Meredith didn't know how to do this before,
didn't she? But she knew how to do calculus before she
She did.
She has progressed through trig and
She has done those
calculus, so
things.
she is way, shall we say, way.
All right, now we would have stopped a couple of weeks ago. We would have stopped at this point because we had ones on the main diagonal and at the 0 down here. But we're moving on. We're going to be so bold this time around. We're going to get a 0 here as well. What row operation could we perform that will give us a 0 here without messing up this 1 or that 0 or that 1? In fact, I'm going to go ahead and copy the second row over. We're not touching it. But what should we do to the first row?
Row 1 minus 2.
Say it, yes. Okay, good. Row 1 minus 2 times row 2. Look how nice this is. Row 1, 1, minus 2 times 0, leaves that as a 1. Here I've got 2 minus 2 times 1. Here's the 0 I wanted. And then here, 1 minus 2 times 1.5, so that's 1 minus 3, negative 2. And then here, 0 minus 2 times negative 5, so it's going to be 0 plus 1, 1. And so there's the matrix. The
If
inverse
it goes in
matrix.
the lower row, it's a minus, because when you got the 1 over on that side, you said it was 2 minus 2 times 1, which gave you the 1.
That gave me a 0 here.
How did you get the 1?
This?
No, the one on bottom.
Here?
Yeah.
Oh, I already had it. How do we get it up from here down to here?
No, I was just, so you just carry the bottom row over?
Right,
And
we
does
just-
nothing happens to that?
Right, we left that alone. And we took the first row minus 2 times the second row. Because it is a valid operation, we're row reducing like this, that we can add or subtract. We can replace one of the rows by the sum of that row and a multiple of another, or by the difference of that row and multiple of another. So we just replace the first row with first row minus twice the second row. So let's test this. Let's see if it really is the inverse of the matrix. So we need to go back. I think I've still got 1, 2, 3, 4 in the calculator over here. Maybe is matrix B. I think that's which one is it B?
B.
Okay. So let's put in this inverse that we just found in matrix B. Okay. Will you read those numbers off to me, please?
-2, 1, 1.5, and -0.5.
-1.5. Now, how do I test this?
Just multiply it by B.
Alright, so matrix A times matrix B. Wow, look at that. And that's exactly what it should be. The 2 by 2 identity matrix. One's on the main diagonal and zero's elsewhere. Technically, we need to test it, because matrix multiplication is not commutative, we need to test it both ways. Generally speaking, if it is the inverse multiplying one way, it's going to be the inverse if we multiply in reverse order as well. But let's try it, just because this is so much fun to see that 1001 pop up. Alright, so B times A. Matrix B.
So it's so much fun.
Yes. She is. She's kind of used to my rather sick sense of humor. Okay, and there it is. So we found the identity. We found the inverse. Thank you, ladies. Very good. Did she didn't happen to mention the ending time, did she?
No, I don't think she did.
Okay.
Did she say 10 minutes?
Yeah, she said just give
There
it
was 10 minutes about some, I heard 10 minutes, but I don't remember what it was in reference
Yeah,
to.
she said, well, she just to give 10 minutes of resource, but I figured we'd say this would keep us
Probably
going
did.
on this, so.
Because we don't want Erin to miss too much.
Right.
All right, great, thank you. Okay, well, I think we're just about finished. That was the main thing for today. Do you have any questions about how we arrived at this inverse?
No.
Okay, well, let's do one more for practice. And then I'm going to need to modify the assignment for tonight a little bit. I'll just put it on homework now once I make up my mind. It'll probably be fairly non-threatening, I think.
For some reason in my head, I thought you were going to say variance would be.
No, I don't think so. We didn't get through everything today, so I don't need to do 400 practice problems over something we didn't quite really even get to the final point today. We've made a little progress. How about this one? 1, -4, 2, -3. 2, -3. All right, so if we want to find the inverse, set up this augmented matrix, and we'll reduce it. All right, first step.
2 minus 2.
Right? Check that, please, for me. Yep. Okay, next up.
Teachers, I'm sorry again for the interruption. The bells have been reset. The next bell should ring at 12:03. That will be the end of fourth period, and I have emailed all of you the new schedule for this afternoon.
It's very efficient.
Um,
Okay.
Since we normally work like from top down, side to side, like left to right, do I need to get the 0 in that top spot first, or get the 1?
I would get the 1. I think generally it's best practice to get the 1 here, zeros below it, then move to the next element on the diagonal, 1 there, zeros above and below.
Okay. So then you're gonna say row 2 divided by 5.
Okay. Next.
Row 1 plus 4 row 2.
Good. 1, 0. Let's see. Plus 4, 1 minus 4 times 0.4 is 1.6, 1 minus 0.6, negative 0.6. Okay.
Yeah.
All right. Okay. And there it is. Now, let's go back and we're going to use the calculator again, but this time we'll make it do the work and see if it's the same result we did. So that matrix, I'm going to ask you to read it to me, but enter it in the calculator here.
The original matrix.
Oops. I can work this newfangled thing. Okay, here we go.
1, negative 4, 2, negative
All right, do you remember how to use the calculator to find an inverse of a matrix? Well, we go to the matrix, choose the one we want, and then we press the inverse button right here. X inverse.
3.
Enter, boom, there it is. So the calculator makes short work of it, but again, unless you have gone through the long way, the manual method, it's easy not to appreciate what the calculator is doing for you. But look at this, we've got exactly, whoops. Same thing here. Negative 0.6, 0.8, negative 0.4, 0.2.
Yay.
So there it is. And now you know, as Paul used to say, the rest of the story. That's all about, well, not all about, but much about matrix inverses. Okay, a couple more minutes. Let's see what else was on the list for today. And class didn't want to getting cut short by much because of the little malfunction. Okay, we did that. We did that. We did that. We did that. We didn't talk about this. Let's briefly address this. Why does a matrix have to be square in order to have an inverse? Did you know that? That only square matrices have inverses? So the dimensions have to be 2 by 2 or 3 by 3, or it could be a 1 by 1 or a 10 by 10. But the number of rows has to be the same as the number of columns. Let's talk about why it is. That's an important point.
Well, I know that it has to work both ways. You don't have to be able to use difference because A equals B, but you can always do that with matrix that don't match.
That's exactly right. You're exactly right. And let's say that again loudly so Erin can hear you. Cyberspace.
So you have to take, because when we were doing the matrix, it had to work both ways. So B had to, like your matrix. So when B times A has to equal A times B, but when you have matrix with different dimensions, that doesn't always work.
Okay, let's name our matrices A and A inverse. Tell me about A and A inverse. What has to hold if this really is an inverse of matrix A?
Then A times A inverse has to equal A inverse times A.
A times A inverse has to equal A inverse times A, and both of those have to equal what?
The inverse. No, the identity matrix.
Right. The identity matrix. Okay, and so you exactly nailed the reason that only square matrices have inverses. You want to talk through it once again now that we've got some symbols up here on the board?
A times the inverse of A has to equal the inverse of A times A. And since most of the time when you have matrix that are different dimensions, that doesn't always work because your rows in your first have to equal the column. No.
Columns of the first.
Columns in the first have to equal the rows in the second. When you have different dimensions, that doesn't always work.
Okay. So if the matrix isn't square, if A is not a square matrix, we're going to get into issues with dimensions. And in fact, A times A inverse would have a different dimension than A inverse times A. And yet we're told that they both have to equal the same thing, the identity matrix. And the identity matrix, by the way, is a square matrix. So the only way to meet the requirements for an inverse matrix is that it has to be, the matrix we're finding the inverse of has to be a square matrix to start with. All right, very good. You're on a roll today, Garrett. I think you must have gotten a lot of sleep last night or something. You're moving. All right, we don't need to do that because we did another example already. What?
We did that example.
Was that the same one? Okay. I didn't even remember. I mean, I knew we had done one, but I guess I should have. Well, I'll tell you what I did. I pulled it out of my notebook, forgetting about the fact that that is exactly the one that I wrote in my notebook. Okay, one of us is sharp today. All right, so I thought we would do. We've got maybe a minute to do that. Do you have your test with you from last week? If you don't, I've got a copy of the key here. I thought what we would do is use this newfound information we have to see if there's another way to solve some of these problems from the test. I mean, you've probably been thinking to yourself as we're going through these lengthy row operations for some of the word problems that we've done, there's got to be a better way to do this. There's got to be an easier way. And in fact, there is. So if you look at question number 1, would you read me what the augmented matrix was that you used to solve that?
1, 2, 7, 2, 1. Or no, not 1, 3. Sorry.
3?
7, 18, negative 1, 4, 2, negative 13.
Negative 13? Okay. So this really represents a system of equations. 1x sub 1 plus 2x sub 2 plus 7x sub 3 equals 2.
But how do you do this because it's not square?
Oh, well, let's look at what we're really solving here. I'll tell you what, let me get this shortcut because that spell's going to get me. I'm going to ask you to repeat these numbers for me in a second. Here's the system we're actually solving. So 1 x sub 2, x sub 3 equals, what were those numbers on the right again?
2, negative 1, negative 13.
Here's the system we're actually solving. And so what we have to do, if we want to solve for this matrix, this x sub 1, x sub 2, x sub 3 column matrix, in order to get this guy by itself, we have to get rid of this. Now in algebra, you know, if you have like 3x equals 6, you're going to divide both sides by the coefficient of the variable, the 3. Solve that, x equals 2. But here, matrix division is not defined. We found that out the hard way today. The calculator let us know that right now. And so it's not defined. So the best we can do, instead of dividing, you're going to have to multiply by the inverse. So if we call this matrix A, and let's say this is capital X for this matrix, and then this is equal to, how about B? I'm feeling so original today. So if I want to solve for this matrix X, figure out what these 3 variables are, the way I do that is I multiply. I can't divide because division's not defined, but I can take this on the left side, I can multiply by A inverse. And over here, remember, matrix multiplication is not commutative, so I can't on the left multiply by, I can't on this side multiply by A inverse on the right, and then over here do it on the left, or here on the left, and here on the right. I got to go same order. So since I did A inverse times X, A times X over here, we're doing A inverse times B.
The class period that would not end.
I thought we were going to be short on time. We had plenty of time. Almost. All right, so to solve for x, we're going to enter in the calculator matrix A, which is a square matrix.
Okay.
And then we're going to take A inverse times B, and we've got an answer.
Okay.
All right, more about that tomorrow. I will put an assignment, a rather lightweight assignment on homework now tonight. Just going to figure out what that's going to be.
Okay.
All right, see you tomorrow. Hopefully we'll have Erin back tomorrow. Erin, I hope you've enjoyed this broadcast done for your benefit. Adios.